that says phase 1, that's actually phase 2. Regarding these bioretention facilities, we have members of our company working in this research. And so in the second phase of the study, so both those phases did focus on the bioretention performance. And so we'll look at the matching of the flow performance between the model results in the model and then what we actually observed out in the field, and how those bioretention facilities are built in the region, and in retrofits were also studied in this case, and then the local jurisdictions are seeking evidence that the bioretention is actually effective to protect water quality and for treatment. And so all 10 of these studied bioretention facilities were constructed in the last 2 years, and the soil that was used in it was coarser than Ecology's recommendations, and so we got more infiltration actually in these facilities than we thought, and also the foot traffic will also cause some site disruption. And so one excerpt from it is the WWHM model, built from field measurements of each site, adequately represented observations, verifying accuracy of the model's ability to predict performance. So when the facilities were built properly, the model did a great job of accurately showing that this is how the facilities will perform. But that's the caveat, built properly. However, most of these facilities were not designed correctly by the user, and they performed suboptimally, or they just were not built to the proper standard. And so some more of the findings, top areas of the 3 facilities were smaller than what was in the design report, so that's going to cause some issues. Infiltration at times were higher because of that coarser soil that was often used. And then some of the water-loving plants were a mismatch for those well-drained soils, and then some of the shrubs tended to survive better. So when the top areas were not actually built to specification, when the soil used was coarser, obviously we're going to have some problems with that in performance because it's not actually being built to what we modeled in the software. So when we actually modeled it properly, built it properly, the bioretention facilities performed great, did exactly what we needed to. When they weren't built properly, they didn't perform how we need to have them perform, obviously. And so Ecology's outlined recommendations for bioretention design. We need to maintain that top area correctly and the under drain guidance, and then develop a checklist, of course, for engineers and reviewers to make sure this process is being followed properly and it's being built properly. Because we wouldn't cut corners, hopefully, on anything else like a building design or a road. You're not going to accidentally make it the lanes 3 feet shorter on each side, right? We need to actually do this right to make sure it performs to the capabilities that it needs to. And so just some more of the implications, which I've already kind of discussed, is that when they're designed properly, WWHM does a great job at determining how they actually work. When they're not built properly, not so good. So we really need to be thorough as hydrologists and engineers, and when we're using WWHM to actually accurately design these facilities and be constructed properly.